All right. So, hello and welcome everyone. So, we are live right now. I hope I'm audible to all of you. Okay. So, welcome back. Welcome back to this amazing platform Tutee Learning. So, in today's class, we're going to discuss and start with our new topic on coordinate geometry, and that is another new conic section that is basically circles, right? So, in today's class, we're going to discuss about all the important form of equations of circles, and with that, we're also going to see how we are going to relate the various equations in or the secondary equations in x and y, and how do we find out that particular thing related to that the properties of the circles, right? And also we'll see that how we can formulate the different equation of circles in different scenarios, right? So that is the motto for today's class. So let us start. Right now, before I start with this class, I want to say something to all of you. This is that before you start to watch this particular content, it is very important to watch the previous contents. Okay, so please complete the session that I have taken so far on straight lines. Okay, so I've already started with coordinate geometry, starting with the basics of coordinate geometry, and then we discussed about straight lines, right? So please discuss those particular topic, please study those particular topic, and then only you come to watch this particular session over here, right? So without watching the previous topics, it will be a little bit difficult for all of you to basically digest this particular concepts, right? So with this particular things said, let's get started. Okay, so today we are going to start with circles, and if we discuss our circles, what all things we will cover is that we'll try to start with the definition of circle, then we move on to the different form of the circles, right? Different form for the equation of circles, and following that we'll move into the, so let me paste the picture over here so that I can, this is a planner that we all the topics that I'm going to cover, especially in circles, right? So we'll start with discussion on the definition of the circle, right? We'll start with different form of the equation of circles. We'll discuss the position of a point with respect to a circle. We'll discuss about the intersection of a line and a circle, tangent and a circle at a given point, normal to a circle at a given point, chord of contact, equation of chord bisected at a given point, directed circle and its equation, intersection of two circles, angle of intersection between two circles, radial axis, common chord of two circles, and the family of circles. And at the end, we are also going to solve some general problems involving locus, right? So these are the entire syllabus, all topics we are going to discuss in this chapter of circles, right? Now please note, this particular discussion is related to the JEE Mains and Advanced examination curriculum. Okay, and also if you are appearing for any other competitive examination where your 10+2 level, where basically the syllabus is same as that of the NCERT class 11th and 12th, then I think this particular lecture is going to be very useful for all of you, right? So with that particular being said, let's get started with understanding that what is the definition of any circle, right? So what do we mean by the definition of circle? I'd like to discuss about it. So we have already seen that a circle is basically a figure which has a fixed distance from the fixed point, right? So circle can be defined as a locus, can be locus of a point which moves, can be defined as a locus of a point which which moves in a plane such that which moves such that its distance its distance from a fixed point, okay, its distance from a fixed point, that is also called the center, okay, its fixed point is constant, right? So if we get such a particular locus whose the point is varied in such a manner that the distance from the fixed point, distance from a fixed point, which is also called as a center, right? So circle will have some terminologies, and one of the terminologies for the circle is called as a center, right? So this particular center is a fixed point to the circle, and the distance of this fixed point to the variable point is going to be constant, right? So that is what we have defined as circle, right? So based on this definition, we can quickly derive a simple expression for the equation of the circle, right? So if I discuss about a circle like this, so let us say the center is a known point which is given as h comma k. Let us say the center is h comma k. Okay, this is my center, and let us take up any fixed point p which is given as x comma y, and such that the distance from the center and this point P is going to be constant. Let us call the center as C. So what I see, and this particular constant distance, let us say PC, which is also called as R, or it is also called as radius, right? So this particular fixed distance is also called as radius, right? So now we can easily find out the PC distance as x minus h square plus y minus k square, and then square root of it is going to be the fixed distance, that is R. Now if I take square root on both the side, I'm going to end up obtaining a relation which is going to be x minus h whole square plus y minus k whole square is equals to r square, So this is what is called as the general equation of a circle. Okay, so this is the general equation of the circle. Oh, sorry. General equation of the circle. Okay, with center as h comma k, with center as h comma k, and the radius is r. Okay, and the radius is equals to r. So if this is the equation of the circle whose center is h comma k and the radius is given as r, right? So this is what we define as the general equation of a circle, right? So in case if I have the center as 0 comma 0, then this particular equation of circle will be modified to as x square plus y square is equals to r square. Now an interesting way to also obtain this general equation of circle, and also, so from here what I can do is that if I try to expand this particular relation to make it a second order term, I'm going to obtain some terms like x square plus y square, right? And then I will have minus of 2hx minus of 2ky, right? And that will be equals to r square. So let us take the r square term on the left hand side. So that will be minus of plus of h square plus k square minus r square, right? So this is what I will get. Now if you recall from our previous discussion on any general equation of conics in second degree curve or a second degree equation, that was written something as, so if I am writing over here the second degree equation, that was written as x square plus 2hx plus by square plus 2 times of gx plus 2 times of fy plus some constant equal to 0. So what you observe is that in case of a circle, the important consideration is that first of all the determinant that we saw for a pair of straight line, okay, so this particular determinant should not be equal to 0. So this particular determinant should not be equal to 0 for it to be a circle. And also a very important observation, that is your h should be equal to 0. Your h should be equal to 0. There should not be any term containing xy. And then only you will be able to get this particular equation as the equation of circle, right? So then only this particular general second degree curve is going to imply a circle, right? Now we can also get back to the from this particular general equation of conics to the, and also another important consideration is that your a and b should be equal, right? Your a and b should be equal. That is also very important, right? So these all three conditions has to be satisfied in order to any general second degree equation to become a circle, right? So please take a note of it. Now from here we can also come back to our expressions. Let us say I write the general expression of circle since a and b are equal, and let us write the general equation of circle as x square plus y square plus 2 times of gx plus 2 times of fy plus of constant equal to 0. Now let us call this as the general equation of the circle. So this is the general equation of the circle. So this is the general equation of the circle. So if I have this general equation of the circle where my g, f and c are the constants, right? So if I compare this particular equation with my previous derived result, that is h square, and now let us call the center as alpha and beta, okay? So then I will write x minus alpha square plus y minus beta whole square, and that was equals to r square, right? So if I just compare these two relation, from here, what I can obtain is that the center can be obtained, that is alpha comma beta can be obtained as minus of g by 2 comma minus of f by 2, right? So this will be the coordinate for the center. So from this general equation of circle, I can obtain the coordinate of the center as sorry, not minus g by 2, it's g and minus f, right? So it should be minus g and minus f, right? This will be the center. This will be the center. Okay. This will be the center of the circle, right? And along with this, if we want to find out the radius, if we want to find out the radius, then the radius of the circle, that is small r, will be given as square root of g square plus f square minus this constant c, right? So this will be the radius of the circle, right? So if I want to find the center, it is minus g comma minus f, and if I want to find out the radius, it is basically square root of g square plus f square minus c, right? So please take a note of it. It should be minus g and minus f, where it is basically the constant will be not given. It is the constant over here with x is basically 2g, and the constant with y is over here is basically 2f. So please take a note of this so that you don't make a mistake. Sometimes the equation of circle will be given as like x square plus y square plus 5 equal to 0, right? The students make a very terrible mistakes and write the center as 5 comma 0, right? Which is incorrect. So please take a note of it. This constant with x is basically assumed to be 2 times of g. So therefore from here the g is 5 by 2, and therefore the center will be minus of 5 by 2 comma 0, right? So please take a note of this particular thing, because it's going to be very useful and important, especially when I will give you any general equation, right? Now also an important thing to note over here is that in order to this particular circle to be a real circle, this radius, since the radius involves a square root term over here, right? So if you observe this radius over here, it has one square root term, right? So in order to be the circle to be a real circle, an existing circle, the radius should be greater than or equal to 0, right? And that basically gives us another condition for a circle to exist, is basically that g square plus f square minus of c square should be greater than or equal to 0, right? So this is another important consideration for a real circle, right? For a real circle, otherwise the radius is going to be imaginary, right? So for a real circle, this particular condition has to be satisfied. I hope this discussion is clear to all of you, right? I hope this discussion is clear. So take a general note from here that whenever any general second degree curve equation is given, so from this second degree equation of curve, from this particular curve, this is a general second degree curve. Now this particular equation, in order to be a circle, it is that h should be equal to 0, a is equal to b, and this determinant should not be equal to 0, right? So please take a note of this so that you can apply this particular idea to solving any types of problems, right? So maybe now I can give you some problems to solve, and you can try to use this particular idea to solve these kinds of problems, right? So let us take a very simple problem to begin with, and this problem is basically a recapitulation of the previous chapter, that is straight lines, right? So it will help you to understand the concept of circle as well as straight line, right? So please try to solve this problem. Please try to solve this problem. Please try to solve this problem. Okay, so very straightforward problem and very simple problem to start with. And moving forward, we are also going to discuss about the properties of the geometrical relations of circles, right? So whatever geometrical properties regarding circles you have studied in your junior classes, be it class 9th and 10th, you are definitely going to apply those all results in this particular questions. Okay, so please try to recall those particular concepts and try to apply them over here, right? Is this part clear? Is this part clear to all of you? Just try to solve this problem. Okay, is this part clear? Do let me know in the live chat, is this part clear or not? Okay, so please try to solve this problem. So please try to solve this problem and do let me know the solution you are getting or what is the answer you are getting. Okay, so if I try to see this problem, what I can observe is that these two lines the equation of these two lines, the lines that is shown over here, are nothing but their parallel lines. And if a circle, it is said that for the circle, these two parallel lines are the tangents, right? These two parallel lines are the tangents, right? Okay, so if I write down this equation, let us say this particular line is given by this equation, and if I write the second line equation in the reduced form, something like this, these are the tangent of the circle, right? So if I have the tangent, if I draw the perpendicular distance between the tangents passing to the center, then this will give me the, this particular distance will give me the diameter of the circle, right? Because I have a parallel tangent which is like this. Now if I just find out the perpendicular distance between two parallel lines, I will obtain this as my diameter of the circle, right? So from here I can obtain the diameter as, so it is basically 4 minus of so 4 minus of minus 7 by 2, that will be plus of 7 by 2 divided by square root of 3 square plus 4 square, right? And take a mod of it, and this particular distance is going to be equal to the diameter of the circle, right? So from here you have to calculate the radius, and the radius will be, so diameter, if you try to solve the diameter, it will come out to be 3 by 2, right? So diameter will turn out to be 3 by 2. So from here the radius will be 3 upon 4. Okay, so this is the right answer to this particular problem. Okay, I hope this is clear to all of you. I hope this is clear. Okay, so let us try to solve some more problems to understand this particular topic of circles, right? So now we are going to use all of our basic properties of circles that we have learned in the previous classes, right? So using this particular idea, try to solve this problem. Okay, so this is another interesting problem, and these kinds of problems are kind of standard and straightforward problems. So maybe if we'll try to solve this problem, once you try to solve one problem, the rest of the problems are very similar, and you can be easily able to solve the other problems as well, right? So please try to solve this problem, and then we move on to the other types of problems, right? So please solve this problem. Please try to solve this problem. Okay, I'm looking for your live chat. So if you have any queries, any issues, do let me know so that I can quickly help you out. Okay, so tell me the answer. So what is the length of the chord that is cut off by this particular line equation, right? So the equation of the chord is given. So to find out the length of the chord cut off by this particular line from the circle whose equation is given as follows. So if I try to draw a pictorial diagram or a schematic diagram of this particular scenario, what I can see is that there is a circle and whose center is basically at origin, right? Now we have a line which is 2x plus 1, it's something like, let us say something like this, y is equal to 2x plus 1, and the center is somewhere over here. So it is said that you have to find out the length of the chord that is cut off by the circle, right? So if I represent this 2 point of intersection of the chord from here, सोहम खंडारा सर ये टेलीग्राम खुल नहीं रहा है, प्लीज बताइए क्या करना है. ठीक है, मैं देखता हूँ टेलीग्राम क्यों नहीं खुल रहा है. ओके, आई विल चेक विद द टीम. ओके, and I will update the link again. Okay, but for the time being, what you can do, you can maybe also you can contact us on the given number. Okay, the number is already given in the live chat. Okay, please contact us on this number to get access to this Telegram channel as well. Okay, particular on this line AB or this chord AB, this perpendicular from the center will be basically the bisector of this particular line AB, right? So if I apply this particular concept, and then I only thing I have to do is basically, so maybe what I can do is that I can find out by solving this particular circle and the line to get to the 2 points A and B, right? That can also be done. Also, without even doing that, what I can do is that I have the equation of line, I can do a foot of perpendicular, or maybe I take out this particular distance, right? So let us call this distance as P as perpendicular distance, and I already know the radius, which is equal to root 2. So if I just find out P, I am easily going to get the D by 2. So in this small triangle, let us call this particular point as capital D, right? So capital D, this is C, and let us say A, right? So we already know this particular length, which is root 2, and let us find out this perpendicular distance as point P. So this perpendicular distance P can be given as, using the formula, it will be 1 upon root 5, right? 1 upon root 5, right? So that will be the perpendicular distance of this origin, which is a center on the line y is equal to 2x plus 1, right? So if you apply the formula, you will get this 1 upon root 5. So you already have the perpendicular distance, then you have to find out AD distance. So your AD would be equal to square root of 2 minus 1 upon 5, and that if you solve it, out, you're going to get 3 upon root 5. 3 upon root 5. So from here, your AB distance would be just 6 upon root 5. Okay, so from here, your AB distance is going to come out as 6 upon root 5. Is it clear to all of you? Is this question clear? Is this question clear to all of you? Okay, so the answer to this problem, that the length of the chord that is cut off by the circle, by whose chord equation is given as 2x plus 1, the answer is basically equals to 6 upon root 5, right? Now maybe you can solve this problem by finding out the coordinates of A and B, and then you apply the distance formula. However, that way of solving the problem would be a lengthier method, right? So always try to opt for a shorter method, right? And it is a very well said statement that mathematicians are very lazy person, and that's why they've invented or discovered some of the interesting forms of reducing the calculations, right? That's why, and I think it is pretty much well established, right? So you have to think in an interesting manner so that you can reduce the steps of calculations. Okay, so let us now move forward towards solving some more problems regarding the properties of the circle. So let us take this problem. So let me show the problem over here. Okay, so this is another problem, another interesting problem and standard problem as well. So please try to read the problem first of all, and then depending on whatever you have understood, please try to get to this angle. Okay, try to get to this angle, right? So try it out. So try it out. Everyone, please try it out. Try to solve this problem. Okay, so if I try to read through the problem, so let us read through the problem. It is said that an acute angle triangle, okay, an acute angle triangle. पीटी भवेश, यार 11th का क्या हुआ? भवेश, ये तो क्लास 11th का ही है ना? सर्कल्स तो क्लास 11 में आता है. आप 11th का सिलेबस जानते हो? सर्कल्स, स्ट्रेट लाइंस, ये सब क्लास 11th में ही आता है, राइट? सो मैं 11th का ही तो पढ़ा रहा हूँ, फॉलो करो. Okay, so it is said that an acute angle triangle PQR is inscribed in the circle x square plus y square is equal to 25, right? And if Q and R have the coordinate 3, 4 and minus 4, 3 respectively, then you have to find out this particular angle QPR, right? So let us see how we will be solving this particular problem. Okay. And Bhavesh, you didn't call regarding the online classes. Okay, so please call us on the number given on the screen to get enrolled to the online classes. Okay, so since you already mentioned that you wanted to take live online classes on maths, पर सर आप तो डिटेल में नहीं समझा रहे हो, ऊपर ऊपर से समझा के ओनली क्वेश्चन करा रहे हो. भावेश, लेक्चर बिना देख के एक मिनट देख के लेक्चर देख के आप सोच रहे हो कि मैं ऊपर ऊपर से पढ़ा दिया, तो क्या फायदा? देखो, तुम लेक्चर देख ही नहीं रहे हो. ये डिस्कशन क्या मैं ऐसे ही कर रहा था क्या? भावेश जी, चलो देख लो, देखो मैं कितना कुछ चीजें पढ़ाया, ठीक है? बिना लेक्चर देखे आप एक मिनट देखते हो और देखते हो क्वेश्चन करा रहा हो, और आप सोचते हो मैं ऊपर ऊपर से पढ़ा रहा हूँ. शायद आपके पास दिमाग नहीं होगा ये सब चीजें समझने के लिए, इसलिए आपको लग रहा है ऊपर ऊपर से पढ़ा रहा हूँ. ठीक है, एनीवेज, देयर आर सम पीपल हु डू नॉट अंडरस्टैंड वॉट एवर आई एम एक्सप्लेनिंग, सो उनको लग रहा है कि ऊपर ऊपर से पढ़ा रहा हूँ, राइट? एक बार ढंग से फॉलो करो लेक्चर्स को, जो मैं पढ़ा रहा हूँ उसको फॉलो करो, ठीक है? मैं ऊपर ऊपर से पढ़ा के क्वेश्चन नहीं करा रहा हूँ, ठीक है? और ये क्वेश्चन तुम्हारा वो डिफिकल्ट प्रॉब्लम भी नहीं है जो बेसिकली सब बच्चे सबको करा देना चाहिए, राइट? ये वही क्वेश्चन है जो मैंने पढ़ाया अभी क्लास में, उसी के ऊपर से क्वेश्चन दिया हुआ, ये बेसिक क्वेश्चन है, ठीक है। सबसे नहीं हो पाता है, मैं समझ में आता है ये चीजें, ठीक है, बट क्या कर सकता हो, जिनको समझना है वो समझ रहे होंगे, ठीक है, और जिनको समझना नहीं उनको लगता है कि ऊपर ऊपर से पढ़ा रहा हो। एनीवेज, क्या सर डाउट को पूछ लिया आपने तो रोस्ट कर दिया। तुम डाउट नहीं पूछ रहे थे, तुम ऐसे ही बोल दिया कि ऊपर ऊपर से पढ़ा। तुम बिना लेक्चर देखे तुम ऐसे कमेंट नहीं कर सकते हो ना, पहले देखो पूरा। मैं रोस्ट नहीं कर रहा हूँ, मैं तो बस समझा रहा हूँ, ठीक है, ये कोई रोस्ट नहीं था भावेश, मैं समझा रहा हूँ, ठीक है, कि तुम लेक्चर पूरा देखा नहीं और तुमने डायरेक्ट कमेंट कर दिया, ठीक है। देखो मैंने इतना कुछ चीजें पढ़ा दिया ऑलरेडी, तुम लेट हो चुके हो ज्वाइन करते हुए। ओके, तो लेट अस कम बैक, to this particular problem. Okay, so in this problem it is said that again an acute angle triangle is inscribed inside a circle, right? Now if you look at this particular circle equation, it is a circle whose center is origin, right, and the radius is 5. So let us call this a circle with a center origin and the radius as 5, right? And it is said that if R and Q have a coordinate, let us draw some point R and Q. Now if you look at the point Q and R, they are the point lying on the circle, right? So let us say this point as R as minus 4 comma 3 and R as 3 comma 4, right? Now you have to inscribe an acute angle triangle in this manner such that this is an acute angle triangle PQR, right, which is your acute triangle, which is an acute triangle, right, which is inscribed inside it, right? So you have to find out the angle QPR. So this particular angle you have to find it out. So in order to find out this theta angle, what I'm going to do is that without even solving for this coordinate of point P, I'm first of all going to find out the angle that this chord RQ, is subtending at the center. So this particular angle will be equal to 2 theta. So if I get out this particular angle, which is 2 theta, then it is going to be theta, which I am applying by the properties of the triangle, right? So if I am able to find out this 2 theta angle, then I can easily comment on what is theta. And I know I can easily find out 2 theta because that will be tan inverse of, so let us call the slope of the line CQ as M1 and slope of the line CR as M2. So that will be just tan inverse of M1 minus M2 divided by 1 plus M1 M2 and take a mod of it, right? And take a mod of it. So if you solve this particular result, so tan to M2 over here as minus of 1. So therefore your theta is going to be equal to pi upon 4. Okay, very standard straightforward problem. Okay, so just by applying the properties regarding the circles, you can easily solve this problem. Groove Gaming, hello, what's your rank in mains? Everything is mentioned in the description box. Okay, please read the description box. Groove Gaming, please read the description box. Okay, everything is mentioned over there. Alright, so let us now move forward solving another problem, which is another interesting problem, and then with that I would like to give another interesting homework. Okay, so let us first of all solve this problem and then I will give the homework problem, right? So again another question where you are going to apply the concept of your straight lines and you have to apply and find out the area of this quadrilateral, right? So depending on that, you have to find out this area of this quadrilateral where O is the origin, right? So please try to solve this problem. Please try to solve this problem. Everyone, please try to solve this problem. Okay. So let us read to the problem. The question here we have two tangents to the given circle at point A and B meets the point P, which is minus 4 comma 0. And then you have to find out the area of the quadrilateral PQOB, where O is the origin, right? So if you again look at the equation of the circle, this is a circle with the center as 0 comma 0, right? This is the circle at center at 0 comma 0. Okay, this is the circle at center at 0 comma 0, right? So center at 0 comma 0. Now if I draw the circle over here with the radius is 2 and this is my center 0 comma 0, which is given as O, and at point A and B, so let us call this point A, let us call this point B, two tangents are drawn which meets or intersects at point P, right? Let us say these are the two tangents which is drawn to these two circles at point A and B, and it meets at point P, whose coordinate is given as minus 4, 0. Okay, whose coordinate is given as minus 4, 0. So you have to find out this particular quadrilateral area, right? So over here, if we are quadrilateral, right? So to find out this area of this particular quadrilateral, okay. Okay, so how am I going to do that? Very simple. So I'm going to use the properties of the circle. So I have known that the radius intersects a tangent, and that particular radius line is perpendicular to this tangent, right? So this is going to be perpendicular at A and B, right? So I will get two right angle triangle, right? So this particular area of the quadrilateral can be divided into the area of the two perpendicular right angle triangle, right? So that I can easily find it out. So what I'm going to do over here is that I know this radius point, which is basically equals to 2, and this point P is already given to us, right? Very good. I spy, right? So from these two results, what I'm going to do is that I'm going to apply. Let us try to find out this theta, right? So what I can do over here is that I can find out this distance of OP, right? So the OP distance is again going to be coming out as 4, right? So this OP distance is going to come out as 4 unit, right? So if I draw that 4 unit, this is basically 2 unit from here to here on the circle, and another 2 unit over here. That is how it's make 4. So from this right angle triangle PAO, then sine of theta will be equals to 2 upon 4, that is basically equals to half, right? So from here I will get theta to come out as 30 degree, right? Theta to come out as 30 degree, and once I get the value of theta, so I can easily find out the area of this triangle PAO, which is basically equals to half into any two sides into sine of that angle between the two sides, right? So this is theta, so this will be basically equal to 60 degree, right? This is 30 degree, this is 60 degree. So if I'm taking this PO, so I'm writing over here the area of the triangle. So let us say that I know the two sides of the triangle, okay? So if I have a triangle ABC, let us say I know the two sides of the triangle and the angle between them, then the area is basically half into A into B into sine of theta. That is the area of the triangle. So I'm applying that particular formula over here. So since I know the side length OP and OA, then I am applying the angle between OA and OP, right? So from here I will obtain the area of this circle or this triangle to come out as something as so this will turn out to be 8 this will turn out to be so this 2 and 2 get cancelled out, and 4 root 3 by 2, which is again going to be 2 root 3, right? So this will come out to be 2 root 3. Now from here, once I obtain the area of the triangle PAO, the area of the quadrilateral PAOB, this is nothing but 2 times the area of the triangle PAO, right? Because area of the triangle PAO and POB is equal because they are two congruent triangle, right? So from here, the area is going to be 4 root 3. So the total area of this quadrilateral is going to come out as 4 root 3. Okay, I hope this is clear to all of you. Is this part clear? Is this part clear to all of you? So with this, we have discussed quite a few questions regarding the basics of the circles, right? So in today's class, we have discussed how to find out the equation of circle from the locus, right? So we have learnt about how to find out the equation of circle, and from there how to apply that equation of circle to the different form of the properties of the circle, right? 2 root 3, yes, 4 root 3 will be the correct answer, right? The area of the quadrilateral is going to be 4 root 3. Okay, so 2 root 3 is the area of the triangle, correct? Okay, so I hope this discussion is clear to all of you. So now let us I would like to give one problem for all of you to open up for discussion, is that try to find out, let us say, instead of giving you the center and the radius of circle, if I give you that there are 3 points lying on the circle, let us say A point, let us say B point as follows, and C point as x3 comma y3 as follows, right? So let us say we know the 3 points that are lying on the circle. Now using this particular 3 points, you have to formulate the equation of the circle. Based on this, you have to formulate for the equation of the circle. Okay, so I would leave this particular problem for all of you to try it out and let me know whatever form of answer you're getting in the comment section. Okay, so maybe you will obtain a circle equation from here on in form of this required forms, that is x1 y1 x2 y2 and x3 y3, right? So please try to find out that how you can do that, and basis on this I can also modify the problem and say that there are 4 points lying on the circle, and that basically means a concyclic quadrilateral, right? So in that case also I can ask you to find out the equation of the circle, right? So based on this, we will see that we can obtain a general form of a result which we can use in our upcoming discussion of formulation of the equation of circles, right? So please try to solve this problem, okay, and do let me know whatever answer you're getting in the comment section. Okay, so with this I would like to conclude the session over here. Thanks a lot for joining us on live on this particular platform, and if you're new to this particular channel, please subscribe to the channel and also hit the bell icon so that whenever we are live you get a direct notification, right? And also please share these videos with your friends and your juniors or maybe your relatives so that we can reach out to all the masses, okay, because these contents are available for free on YouTube and we can basically watch this on our comfort zone, right? Yes, I'm currently in IIT Kharagpur. Yes, math is easy with Ashwin. Okay, is this part clear? Is this part clear? Okay, so with this, thanks a lot, and I hope to see you soon in our upcoming lectures. With that, I would like to conclude the session over here, and we will meet again in the tomorrow's class. Thank you and all the best.